let's get going because there is another talk after my talk. So first of all, what's Micronaut? Micronaut is an open source JVM framework. You can write Micronaut applications with either Java, Groovy, or Kotlin. We have a lot of Kotlin adoption. Java is our most popular language. Probably the mix is around Java 65 or 70%, Kotlin 25, and Groovy the last remaining percentage. Uh, Currently, the version of the framework is Micronaut framework version 4, which supports the baseline of the framework is Java 17, and you can use 21 or 23 if you want, but essentially the latest LTS that Micronaut 4 supports is 17. If you, for whatever reason, you need to be on on Java 8, Micro 3 still supports Java 8. So what is Micro at its core? As I was telling you, it's quite new, but not really. It's mature enough, so it has been around already for more than 6 years. So I think the first release was autumn 2018, and you can build any kind of application. So you can build, even the name of the framework says Micronaut, and you may think about microservices. You can, of course, build microservices with Micronaut, but you can build monoliths, you can build serverless functions, you can build command line applications. So it's really, we like to say it's a foundation framework that you can use to build any kind of applications. And there is a talk after this one, which talks about annotation processors. And Micronaut at its core, the beauty of the framework is that it doesn't use any reflection at all. It basically generates extra bytecode at the compilation time. So you have your classes, and we will use annotation processors to visit them and generate extra bytecode, which allow us to do things such as dependency injection, validation, all of that without, or bin introspection, all of that without using any reflection or runtime proxies. Yeah, as I was saying, the idea of Micronaut is that we generate at build time as much as possible. So we will generate annotation metadata, AOP proxy. So when you are using something like an add transactional in your method because you are using persistent, that AOP data round advice, we will generate extra information at compilation time, bin introspection, etc. And at runtime, what we don't do is we don't do any reflection, no proxy generation, no dynamic class loading, no class path scanning. So essentially, nothing that you may imagine. So dependency injection, and this is related to the question about Marian about using standard compliance, and you will see hopefully through this talk that we are compliant with many standards. So at its core, the dependency, at its core, Micronaut is a dependency injection engine, right? And we use the standard JSR 330, so the add inject, the add singleton from Jakarta, all of those annotations that you probably are used to seeing. Configuration, we support configuration injection with properties files, with YAML, with TAML, with Groovy, with config4k. If you are on the Kotlin side of things, for example, when you generate an application right now, we'll use properties file, but for a long time we were generating applications with YAML, and if YAML is your cup of tea, you can still use it. Validation support, this is again related to Marian's question about standard support. So Micronaut validation is a subset of the bin validation specification version 2. You can use either Micronaut validation or you can use Hibernate Validator, which is the reference implementation. So both implementations, and in your code you will use a standard annotation. So you will use the standard add not blank, add not null, add pattern. So the standard validations, no proprietary annotations here as well. We use a standard as much as possible. AOP, aspect-oriented programming. So this relates to the typical annotation that you will add in a method. Again, all of this is compile time, reflection-free. Micronaut HTTP client here. I am quite happy that we have two HTTP clients implementation. One of the things that you will see throughout this talk is that Micronaut is quite It's quite give you the choice to the developers. So we have often we have several implementations of the same API. So the Micronaut HTTP client, we have one Micronaut HTTP client based on Netty, and it is the one that has more features. But then we have another implementation that many people will use. And it will be sufficient for them, which is based on the built-in HTTP client of the JDK. And so when you use Micronaut, you don't need to add an extra HTTP client dependency. You don't need to use something like retrofit or something like that. We give you an HTTP client. So Micronaut is a framework that has batteries included. So anything that you need should be there for you. Build agnostic, you can build your Micronaut applications with either Gradle or Maven. You don't need even to use our official build plugins because Micronaut at its core, it uses standard Java API. So we use the standard annotation processor API. So you don't need to do that, but we ship build plugins. We ship a Micronaut, a Gradle build plugin, and a Maven plugin, which it will basically give you some things easier to get started. So, for example, the Micronaut Gradle build plugin will transitively apply the Java application plugin. It will apply also the build tools native plugin. So it is really easy to essentially generate a native image immediately of your application if that's what you want to do, and things like that. Test framework agnostic as well, as you see. The choice is yours. We support your Unit 5, we support the Spock, we support code test. We have some extra integrations for the Unit 5 to allow you to do dependency injection as a method parameter and things like that. But yeah, whatever the testing framework that you want to use, that's probably covered by the framework. Again, another thing that we are quite different from other frameworks is we are reactive library agnostic. You can use Project Reactor, you can use RxJava 3, RxJava 2. Whenever there is a reactive API in Micronaut, you will see a publisher. Under the hood, when we use reactive programming, we are using Project Reactor in the framework, but the public APIs, they all use publisher. Cloud agnostic. So you can deploy Micronaut applications to AWS, Azure, Google Cloud, Oracle Cloud. We ship modules for each of them. So we have integrations that makes you easier to go to any cloud vendor. So we have integrations with things such as AWS Lambda, such as Azure Functions, Google Cloud Functions, Oracle Cloud, of course. So we support, yeah. If you want to go to the cloud, Micronaut, being a modern framework, has you covered. Native image. So Micronaut and GraalVM are probably a match made in heaven. The reason is that Micronaut doesn't use any reflection. And that's perfect for GraalVM. So GraalVM supports reflection, but when you use reflection, you have to whitelist it. And since Micronaut doesn't use any reflection, you don't have to do that effort at all. But nonetheless, if you use any third-party library, because you are using, I don't know, Micronaut plus Liquibase, we have worked heavily with the GraalVM team so that on your part, often you don't have to do anything, because if those libraries, they use third-party reflection, we will see the reflection configuration necessary to make it work. And as I was telling you before, all the necessary plugins integration to make you easy to generate a native image, either directly or within a Docker image, all of that is extremely easy to do. Runtimes. The default runtime in Micronaut is Netty, but you can use a several runtimes such as Undertow, Yeti, or Tomcat, or you can deploy a Micronaut application written with controllers to an AWS Lambda function connected, for example, to an Amazon API gateway. So really, the runtime is kind of an implementation detail. By default, you will be using Netty, but that's something that you can change easily. For messaging, we support things such as Kafka, NATS, RabbitMQ, MQTT. You can build, for example, applications using Kafka and basically have just a pure Kafka listener, no controllers. Database migration tools. We are quite opinionated about this. We want you to use database migration tools, and we have great integration with, I would like to say, the highest open source solutions such as Flyware and Wikibase. For persistence, we have a great story with Microdata. So Microdata, if you have not tried, try Microdata JDBC, which will give you like a repository pattern where all the things, all the queries are pre-computed at compilation time, and you're gonna get extremely fast. You're gonna get extremely fast queries, but also extremely fast developer productivity because you are gonna get like an immediate feedback loop when the queries that you are writing they don't even compile. So microdata has two flavors, actually have three flavors. It has microdata JPA, where you can use microdata plus Hibernate. You can use microdata JDBC, as I was saying, and you can use microdata MongoDB as well. And then we have other persistence implementation. For example, we support Eclipse Store, which is really high performant in-memory persistent, basically. And then we support things such as Juke or Neo4j, Redis, etc. So a huge work has been done in persistence so that the developer experience is extremely nice. For example, in persistent, we support, for example, multi-tenancy. So you can use multi-tenancy with a column, you can use multi-tenancy with a database, with another database, or with a database schema. In terms of views, which is a model that I like a lot, this is the model that you will use to render server-side HTML. We support things such as Turbo HTMX, but we support many template rendering engines such as ThimeLeaf, Pebble, Soy, Rocker, JT. So all the new kits in the block and the old ones. So for example, we support also like Apache FreeMaker, Velocity. So completely agnostic in terms of views technology. We support OpenTelemetry as well. We have a great tracing module that allows you to use OpenTelemetry to integrate with Zipkin and Jaeger. In terms of service discovery, we have integration. We have a service discovery module. If you are like building a microservices architecture, you can connect to something like Consul. In terms of security, and this is again going back to the question from Marian, do we support the standards? Of course we do. So in security, you can use the standards security annotation. So you can use in your controller permit all, roles allowed. We support the standards, the OpenID Connect, OAuth 2. We support JWT, JSON Web Token authentication, cookie-based authentication, session-based authentication. We are releasing a CRF mitigation APIs as well. So really robust and easy to get going security solution. In terms of error handling, again, we support a couple of standards. We support BMD error as a way to describe errors in your API. This is the default. If you want to use something else, which I prefer, you can use problem JSON by just adding an extra dependency. In terms of monitoring, we support things such as Micrometer, JMX. In search, we support OpenSearch, Elasticsearch, have a module for GraphQL. We have an amazing module for OpenAPI against another standard. You can generate an OpenAPI specification of your API. So OpenAPI is kind of the de facto standard for documenting an API. And the beauty is that we will generate this at compilation time from your code. So you just write your controllers, and at compilation time, you add the OpenAPI module, and it will generate an OpenAPI specification in your class path, basically. We have a cache module. Again, the cache module uses the standard cache JSR. I forgot the JSR number, but essentially the standard one. So you can use any of the standard implementation of cache. So you can use InfiniSpan. You can use Eclipse Store also that supports a cache module. Yeah, all of them that you can use. Email, we have a great integration with email, so you can send your transactional emails using SendGrid, using something like Amazon Simple Email Service. Yeah, all of these typical transactional email providers, we support that. To generate, to generate command line applications, we have a great integration with Pico CLI. Um, we know that many of you are deploying via Kubernetes, so we have a great Kubernetes integration as well. And getting back again to the standards question, you have two ways of writing the routing of your application. So you can either have controllers with methods such as at get, at post, at batch. But if you prefer to use JAX-RS, we support JAX-RS as well. So you can just add the JAX-RS module, and instead of writing controllers, you can just write resources. So as hopefully, Marian, I can get you convinced that yeah, we have many pieces to avoid vendor locking. That's kind of not what we want to achieve. We want to give you the best experience, and when possibly, we rely on standards to do that. And I think I have 5 minutes for a demo, but if there are any questions, I'm happy to take them. Um, and if you have questions, please leave them on the chat. I'm gonna leave the chat here open in another monitor that I have. So what's the home of Micronaut? The home of Micronaut is micronaut.io. So you can go here to micronaut.io and just go and click generate application. I'm gonna say demo conference and click download zip. You can also generate a Micronaut applications directly via IntelliJ as well. We have great integration also with Visual Studio Code. So this is a Micronaut application. This is the default Netty application. I'm gonna come here. I'm gonna write here a hello world controller. And let me come here and add a package here. And I'm gonna do add controller. And instead of returning a string, I'm gonna return a map. And I'm gonna do here collections singleton map. I'm gonna say message. You have seen a hello world demo a million times. This is gonna be million and one. So I'm gonna put this in the so my code by default assumes that you are writing JSON. So I'm gonna run the app. The app's gonna start on port 8080. So if I go here to port 8080, sorry, not port 80, but port 8080, you see the hello world here. So how does this work? So essentially at compilation time, my code has generated, let me try to do, hopefully you're able to see it. Let me make it bigger. So at compilation time, my code generates extra bytecode. So you see, this is the class that you wrote, and this is the extra bytecode that my code will generate. And this essentially allow us to essentially do all these compilation, all these dependency injection, etc. So I could here come and to show you dependency injection. So we support dependency injection, constructor injection, field injection, etc., etc. But let me actually show you something else because I will have a lot of time for a demo. So I'm going to show you. I'm going to go here. I'm going to open a terminal. Let me go out of. Let me do. So I think I downloaded this to. So this is the application that we just downloaded in my terminal. I'm gonna use a GraalVM distribution, and I'm gonna do here native compile. And this is gonna generate a native image of my application. And if there are any other questions, any standards that you think we should support that we don't support, happy to take them, or any other questions, of course. So this will generate a native image for my operating system. So I am running on macOS. We have another one which is Docker build native, which will generate a native image within a Docker container, and that's also really useful in your day to day. So native image, especially when you are doing a Zoom call, can take a little bit, but we are almost there. But yeah, so we have to finish. So 1 minute and we'll wrap it up because there is another talk that needs to start. So the native image finished building and it crashed because I already have the Java application running. Let me stop the other one. And as you see, a native image starts immediately.